rich is like a girl being pretty.
Why does anyone care? Why?
By the look that's in your eyes.
What is called?
Wonder why you're on your own. Gotta make it out alive.
Literally no one knows.
Hey, Vsauce, Michael here.
When researching quantum physics, I realized that you can write 10 books about every 5 words that there are in a Google search, and that's when I decided that I wanted to give up. Did I get anyone? So quantum, the word quantum, it just means like really super tiny amount of things. It's the lowest amount of a thing that a thing you can have a thing. You know what a particle is? Particle, like, you know? But quantum particles are just like subatomic little buggers, you know? And then those, multiple different things that they can do. Basically, they made the universe big.
No, they didn't.
You know, I'm a little confused because I said that.
Yeah, they made the universe.
No, they didn't. No, they didn't. The literal screenshot that I took of Google doesn't say that they do. So why did I quarks are a type of quantum particle? So there's that also. But I'm gonna be covering quantum mechanics, quantum physics, quantum particles, whatever. I have 10 minutes and see if I got a good grade or not. Okay, so I already explained that subatomic particles are basically just forms of matter that are so tiny they're smaller than an atom, right? When you're at such a small scale, the particles kind of have different rules to them, like they can be in 2 places at once, they can have a constantly changing state of matter, they can also be waves and particles simultaneously, which, I mean, that's basically what I said, but that's called wave-particle duality. It's like gambling. This is Schrodinger's cat. So imagine there's a box with a cat in it, and then the cat can either be dead or alive due to a quantum particle. And the quantum particle is constantly changing from dead alive, can be same at both time, whatever. Quantum particles can just be in 2 states at the same time, so it's like a constant RNG. It's like gambling. So when you open the box, the cat might be dead, might be alive, or it might be both at the same time. That's why quantum particles can be used to make super tiny quantum computers.
So Microsoft figured out a way to make a bunch of those qubits like right next to each other, and they created this chip, right? And this is like new. This is this year, February, I think. And basically, they compact all the qubits right next to each other. They have 1,000,000 qubits on this tiny chip that fits in your hand. Meanwhile, other quantum computers are giant, and they only fit like 135. The 1,000,000 qubits has enough. It has more processing power than every single computer on Earth combined. Like, how is that even?
I also forgot to mention quantum entanglement, I think. Quantum entanglement is 2 quantum particles can be connected to each other seemingly by nothing. Seemingly by nothing. They can be however far away or close as you want, but they, for whatever reason,
Literally no one knows.
the quantum particles are just like,
Treat me like what
they like each other, right? They stay connected no matter what you do, and that is also something that is used on a small level to create technology. With quantum entanglement, if you do something to one quantum particle for whatever reason, the same thing happens to the other. That's like the defining characteristic of being entangled. Very ultra-filtered milk. So Heisenberg's uncertainty principle basically states that the more you try and locate the position of a quantum particle, the less you'll know about the speed of it, or vice versa. This is because measuring at a quantum level will never be as precise. And it's like, say you're measuring how far someone will run, right? And you want to get it down to like millimeters. The more you focus on how much they run, the less you'll know the actual speed in which they run. So that's kind of what it is on a quantum level, and that's...
The Heisenberg uncertainty principle is important because it highlights a
I don't know why I care about that.
You say pandemic. Yo. Oh, you want to see a pandemic?
I'm but my house blew off the hill with the mean view. Nice house if you look.
And you might be wondering where I am right now, and that's not important. What are the applications of quantum mechanics in everyday life? Like, why should we care, basically? Quantum particles can be used in a ton of things, actually. Their technology is what helps make transistors, which are the things that power computers and whatnot. Also, something called quantum dots can be used to enhance MRI, like medical diagnosis. I believe you can also shoot quantum particles at cancer cells, and that is something that can help to get rid of tumors and whatnot. Something called quantum tunneling is what's used in SSD and flash drives to store data. It basically processes electrons, I think. The quantum aspects of atoms and photons are used to harnessed to create lasers, basically. Quantum particles make up a lot of the stuff that we don't really care about specifically, but it still matters in the scheme of the world, so I think it's still cool to know about, like, what quantum particles are. And I'm not trying to say, like, they're super cool or anything, I just picked the topic because I liked it. But hopefully what you get out of this is, like, the role that quantum particles play on Earth